I believe this is number 68. I hope it's number 68. It might be number 69. If I'm wrong, y'all fix the number. This is angles of elevation and depression. So how can you use trigonometry to solve real world problems? And scholars will solve problems involving angles of elevation and depression and use angles of elevation and depression to find the distance between two objects. So, an angle of elevation is the angle that is formed by a horizontal line and an observer's line of sight to an object above the horizontal line. So, essentially, angle of elevation is going to be straight across and up. So, straight across and up. And then an angle of depression is an angle formed by an horizontal line and an observer's line of sight to an object below the horizontal line. So, straight across and down, straight across and down. So make sure you take some time to write this out. Probably draw the picture as close to as possible so you can know the difference between an angle of elevation and an angle of depression. Okay. So an angle of elevation and depression, angles of elevation and depression to two different objects can be used to determine the distance between those objects. And so the angle from two different positions of observation to the same object can be used to estimate the object's height. So we're going to use both of these in our examples that are coming up. So first one, circus acts. At the circus, a person in the audience at ground level watches the high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet above the ground. How far is the audience member from the base of the platform? If the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees. So we need to know how far away the audience member is from the base of the platform. So when I'm looking at this particular picture, it's already here. I essentially need to find this distance here, which is already labeled on our picture as X. It's also important to know that they say that we are looking at a 5'6" tall acrobat. So that means that we are looking here at this line to make our triangle, and then we need to look at this height, which instead of 25 is actually going to be 30.5, because we need that information we need to include the height of the gymnast. So we're going to put 30.5. All right, and so then of course my angle here is 27. I know the opposite is 30.5, and I'm trying to find X, which is the adjacent. Opposite and adjacent is tangent. So the tangent of 27 degrees is equal to the opposite, 30.5, over the adjacent, which is X. Then in order to solve a problem like this, all you're going to do is switch the X and the tangent. So X is equal to 30.5 over the tangent of 27. Then I'm going to take this and put it in my phone. So give me one moment. All right, so then this is going to be equal to 59.86 feet, which is approximately 59 feet 10 inches. Okay, next. Maria is at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what is the horizontal distance from the seal to the cliff to the nearest foot? So the angle of depression is 52 degrees. So if you look over here on the image, the angle of depression would be straight across and down, right? So 52 degrees here. Now, straight across would be parallel to what is in the water down here. So these two lines would be parallel. Looking down at the seal would be the transversal. Those then in turn would be alternate interior angles. And so this angle down here at C is also 52 degrees. And so that's where that 52 comes from. And then we know that the height of the cliff is 40. So we need to know this distance down here at the bottom. And we know the opposite. We're trying to find the adjacent. So the tangent of 52 is 40 over x. Again, those can switch. So x is equal to 40 over the tangent of 52. So let me figure that out. So x is equal to 31.25. It says round to the nearest foot. So that's going to be 31 feet. And then our last example, Vernon is on the top deck of a cruise ship and observes two dolphins following each other directly away from the ship in a straight line. Vernon's position is 154 meters above sea level. The angle of depression to the two dolphins are 35 degrees and 36 degrees. Find the distance between the two dolphins to the nearest meter. Okay, so again, we can use that same concept of here is the angle of depression straight across and down. And that's for both dolphins. It's parallel to the water. So if those two angles up top are 35 and 36 degrees, then these angles here are 35 and 36. And it's kind of hard to see, so let me try to fix that. So this angle and this angle. This is 36. This is 35. All right, so I'm going to be trying to find x and then y. Okay, so if we have the angle, we know the opposite and the adjacent. So then that means that the tangent of 35 is equal to 154 over y. So then y is equal to 154 over the tangent of 35. And so that's going to give you 1. And then we know that the tangent of 36 is equal to 154 over x. So x is equal to 154 over the tangent of 36. So I'm going to put both of these in my calculator. So y would be equal to 219.93. And then x would be equal to 211.96. And it says find the distance between the two dolphins to the nearest meter. So I'm going to subtract. So it's to the nearest meter. So I'm going to do 220, because this rounds to 220, minus 212, because this rounds to 212. And that is equal to 8. So they are 8 meters apart. And that's it.